Okay, section P.5 is on factoring polynomials. The assignment is here. The first thing you should do when you look at a polynomial is to determine if there's something you can take out of it, simply by dividing it out. So if I see a 10 and a 4, what's the biggest number I can divide out of both of those? 2. X cubed and x squared, the largest amount I could take out of both would be x squared. So as I divide, 10 divided by 2 is 5, x cubed divided by x squared is x, and minus 4 divided by 2 is 2, x squared divided by itself leaves you nothing left over. There you go. I have factored out an x squared, so there is my simplified version of the polynomial. Now here, I have two terms. I have this one, and I have this one. What do they have in common? Well, they both have x minus 7. So I can factor that out of both of these, put it at the beginning, and then what is it multiplied by? Whatever's left over. If those two go away, I get 2x plus 3 left over. Now, factoring by grouping basically means that you have a 4-term polynomial, 1, 2, 3, 4, and you can look at it in groups, the first two and the second two terms. The first two terms I can factor out an x squared, which leaves me with x plus 5. The second two I can factor out a negative 2, which also leaves me with x plus 5. So I have a term here and a term here. What do they have in common? X plus 5. So I'm going to factor out the x plus 5. And what do I have left over? X squared minus 2. Factoring just regular trinomials, you've done this before. You're looking for two numbers here that multiply together to be 40 and add to be 13. Hopefully you can come up with 8 and 5. 8 times 5 is 40, 8 plus 5 is 13. Or these two. Looking for two numbers that multiply to be negative 14, but when you add them together you get negative 5. And again, hopefully you can come up with negative 7 and positive 2. Now, if you want to factor this by grouping, this is kind of a strange variation on this technique. Basically what you do is you are looking for two numbers that multiply together to not be negative 7, no. They're looking for two numbers that multiply together to be negative 42. That comes from multiplying this number and that number. Okay? But then add up to be 19. So what are the two numbers that multiply together to be negative 42 but add to be 19? Those two numbers are negative 2 and 21. Now we don't just throw them in there and we're done. This is a little different technique. If you don't like it, that's fine. I'm just showing you another way to do it rather than guessing and checking when you have a number in the front, okay? So, multiply these two together, that's your product number. This is still your sum number. Okay, so I find my two target numbers of negative 2 and 21, add together to be 19, multiply together to be negative 42. Now what I have here is I've written that out as negative 2x and positive 21x. And now I can factor by grouping, by saying, okay, these two have what in common? They have 2x in common. So I factor that out, and I get 3x minus 1. These two have a 7 in common, so I'd factor out the 7, and I get 3x minus 1. So again, I have two groups. I have one term here and one term here. Both of them have 3x minus 1 in common. So I'm going to factor out the 3x minus 1 out of both of them, which gives me 3x minus 1 times what's left over, which is 2x plus 7. If you don't like that technique, you can always guess and check. I just want to show it to you. I'm going to show it to you one more time on the next page. So here, we're looking for two numbers that multiply together to be our product here of 3 times 4, which is 12. But when you add them together, you get negative 13. Well, obviously, negative 12 and negative 1 multiply to be 12, add to be negative 13. Okay, so I'm going to rewrite this, and I'm going to separate the central term here into negative 12xy and negative 1xy. And then factored by grouping. So if I'm looking at these two, in fact, I can factor out a 3x. And these two I can factor out a negative 1y. And what's left behind in each one of these is the same thing, is x minus 4y. So if I factor out the x minus 4y, I get left over 3x minus 1y. And there you go. I factored the trinomial. Just a little different technique, that's all. Don't let it scare you. If you don't like it, don't use it. Factor the difference of two squares. Okay. Now, you have to start looking in this class for things called perfect square binomials. That means that each term is a square of something else. X squared is x squared, and 81 is 9 squared. So if you have two things that are squares and a subtraction in between, nothing else, that is a perfect square binomial, which can be factored into two terms that look like this, x plus 9 and x minus 9. So if I had x squared minus 100, that'd be x plus 10, x minus 10, or x squared minus 25, that'd be x plus 5 and x minus 5. Or sometimes there's a number in front. This 36x squared is 6x, quantity squared, and 25 is 5 squared. So it's the same concept, just add another number in there. First term is 6x, second term is 5. One's plus, one's minus, done. This is still a perfect square binomial. Same thing down here. If you have 81, x to the 4th minus 16. You may not think of an x to the 4th as something squared, but it is. X to the 4th is x squared squared. So basically you would have 9x squared plus 4 and 9x squared minus 4. Now, I know I just circled that, but that was my mistake, or boxed it. I messed up. Because, you know what? We can keep factoring. They want us to take things apart, break them down, right? We're factoring. So this actually can be factored one more time because that 2 is a perfect square binomial. So the first one is not because it's got the plus in between, but the second one is. So I can actually keep going one more step and break this down because 9x squared is 3x quantity squared and 4 is 2 squared. So I can call this 3x plus 2 and 3x minus 2. This is actually my final answer, not this. Oopsie. Whoops. Okay, there you go. So look for that. Sometimes with these particular types of questions, you can go an extra step at the end. Okay? So, hint, it says on the side here, number 10 involves factoring more than one step. So, look for questions like that on your assignment. Factor the perfect square trinomial. Well, this one should be pretty easy. This is just x plus 7 times x plus 7. But when we want to simplify that completely, you can actually put this together as x plus 7 quantity squared. Because there's two of them. Something times itself is that thing squared, right? So we can write it like that. All right. And then this one's very similar. This can be factored into 4x minus 7 times 4x minus 7, and therefore that can also be written as quantity squared. That thing times itself is just that thing squared.